out in January. I bought myself a little Christmas present. Actually, bought my wife the shirt as well, different size. But anyway, got my little NASA shirt because in Math 2 honors, we're talking more about. And hey, and I showed you this. Did I show this class the space telescope? The animation. I think it was all you guys. I don't know if I showed fourth hour. I should have, because actually someone emailed me about the James Webb Telescope, and we talked about it a lot with them. But that's going up in December 22nd. I actually read a story today that they just fueled up the rocket. I can't believe they're fueling it up this early. There's so much preparation to make sure everything is perfect, so there's nothing catastrophic that happens. But this is what we're going to do. This is what math is, and it kind of does correlate to what I'm doing with Math 2. I just showed them the beginning of a stats movie called Prediction by the Numbers. And that's what math is really all about. This is why we graph on a coordinate plane. Is we collect data, then we look at the data, and then we make a prediction. What is this data doing? Let's get an equation on this data that's good. Then we can use that equation, what's going to happen in the future. Simple as that. Very simplistic concept. So let's just look at this picture. This data, does it look perfectly that a graph would match that data? Yes or no? Not perfectly, right? But wouldn't it look like what kind of thing would go through that and the data would be close? What's the equation? Starts with an L. Linear. But it wouldn't be perfect. Now, maybe one thing that you need to write down is this idea of this correlation coefficient, R. Don't get overblown by this. Actually, when I taught stats, we had a regression, and that's the name of this, doing regression lines. Regression means go backwards, regress, look at the data, and from that data in the past, put an equation on it, a regression line. All right, in this case, that's why they're called regression lines. But we're going to go further than that. It could be regression exponential, logarithm, ln, or quadratic. It could be anything. I'm going to show you that in our calculator, what you need to strive to find. Okay, so now what is this data doing? Increasing or decreasing? 3, 2, 1, go. Increasing. So this would have a correlation coefficient, R, very close to 1. Don't worry about why 1. It's complicated. As a matter of fact, in stats, we analyze where that R comes from, and I can't remember. I would have to pull my notes out again and see what that formula is. It's very complicated. As a matter of fact, this is what R is. It's a calculation about, if I throw this line in here, how far away these points are from that line. The farther away they are, the less it's close to 1, that R value. That's all you really need to know. And by the way, we're going to go further than R. We're going to look at R squared, which is just whatever the R value is, squared. Okay? Now, what kind of data is this? Positive or negative? What kind of, that's negative. So your R value would be negative in here. That just tells you that it's a negative, it's going down. But it's a strong negative linear correlation. Not perfectly -1, but pretty close to -1. It actually is a little bit, you're actually supposed to say greater, but a little bit less than negative. It'd be like R equals -0.95. That's what that would be for a correlation coefficient. This would be close to like R equals 0.95 or something like that. Okay, and that's what this says over here. When R is in between 1 and -1, don't worry about where it comes from. It's a superiorly complicated formula. All right. When it's positive, there's a strong. When it's closer to R and it's negative, there's a negative linear. When it's really close to 1, it's strong linear. When it's really close to 0, there is weak or no linear. We're going to go further than linear. Okay, look at this one. Strong or weak compared to that one above? Weaker. So this would probably be R equals 0.9 something. This would probably be R equals 0.7, just making guesses. When I draw a line in here, the distances those points away are greater. That's what the formula really calculates. How how far are the data points from the line, the best line fit. It actually gives you the best line fit. And then this is a strong or a weak negative. And look at this last one. When you get data like this, there's not much predicting you can do. That's a scattered set of data. This would be an R equals 0 situation. So I just want you to know that R comes from this complicated thing. You are looking for R squared, getting as close to 1 as possible. All right? So just put that down. Next, let's go up to some data values, and I'm only going to do the minimum wage thing. I'm not going to do the purchasing power. So the point of this is the worksheet that you grabbed, it's going to be super fast. So there's going to be no writing other than the answer from your calculator screen. If you don't have a graphing calculator, you actually make me sad because I told you you needed one all year long, and but we kind of avoided that. All right, we used to use it a heck of a lot more, but now we just kind of cut our losses because we know a lot of people don't get those things. All right, and then what we're going to do is show you how I can take this data and look at it on my calculator. So this is where we open up our calculator, you calc people. Okay, where is it? There it is. I got it ready. And actually, I do want to show you some stuff. Clear. Get this out. Clear. That was from last hour. Here's our starting point. Hit stat. I love this calculator thing on the screen now. You can see my red, what I hit there. So hit the stat button. And actually, you are going to hit stat edit. Press enter. Okay, first of all, do you guys see L1, 2, 3, 4, 5, 6, right? Correct? Does anyone have any numbers in their list like I do? Yes or no? You know why you probably don't? Because at 3, 4, 5 times this year, I went around and deleted your calculator memory. And then we've never done anything with the lists feature. So when you delete your calculator memory, when you hit second plus 712, it does clear all lists. Okay, but I'm going to do this. And I always do this because I have fear at home you're going to have to use L1, L2 over and over and over again. I fear you're going to accidentally do what I'm going to do. So what's the one way we could get rid of a list? Isn't delete sound like a good word, right? I want to delete this list. Let's all hit that together. 3, 2, 1. Pretend you have numbers in L1. And actually go down before, if you haven't hit delete yet, just type in some numbers. 0, 1, 2. Just type 0, 1, and 2. And then go back up here and then hit delete. Or you can do it if you already deleted L1, fill L2 with some numbers. Oh no, what happened to L1? It completely and totally what? Disappeared. Guess what you should do right now? Delete them all. Destroy, destroy, destroy. This actually happened to me in the later 90s when I first pulled up the TI-81 and we had a list feature. I think it was an 81 had still a list feature. And I accidentally hit delete and I didn't know what to do. And I panicked and I stopped the lesson and said, I'm going to have to figure out how to fix this. And I asked someone else that knew and then had to come back the next day and say, this is what we should have done, class. So now that I deleted the L1 list, this is a true story actually. Go back and delete them all, get these all blank, and then reinsert them. Notice I hit second, and then here's L1's name, 1. And you have to do this while you're all the way up in this corner. Press enter, and then now L1 comes back as a name, but also I didn't delete anything. L1 still has all those numbers I had originally. So this is what you type. You go up to the name L1, and you hit clear enter, not delete. Never delete. But now you know if you delete, just delete them all and then reinsert them. All right, and then you won't be Mr. Samuelis in the late 90s. Okay, go to L2. I don't know why that's not letting me go over there. And then hit second 2, enter. You really only need these two. Oh, look. So I still have that in there anyway. So clear and enter, and now that's gone. You're going to have to do that a few times because I do have, I think, 10 questions I want you to do tonight, which should take you 10 minutes. Maybe further because you do have to plug in stuff. You really don't need anything else. If you delete your memory, if you do a second plus 712, L1 through L6 comes back. It's a default setting. That's another way to clear a list. Second plus 712. And now what I want you to do is do this. We're going to go ahead and do that minimum wage thing. Good, and that's what I want this at. So good. But here's what I'm going to choose to do. I'm going to make 1955 year 55. And you should do the same. Otherwise, you'll get a different equation than I do. This is good for many reasons. 1955 is 1,955. I'm going to actually look for this on my graphing calculator, a stat plot. So sometimes we like to make the numbers smaller so they're easier to deal with. So you go down and type 1955, 55, 60, 65. Oh no, here we go. Another math video of a guy saying numbers. 70, 75, 80. Great years in 80, 85. Oh, freshman year of high school. 90. He's that old. He's half dead. I prefer to say half alive. 100. I'm half the man I used to be. That's a song. Anyone know the group? STP, Stone Temple Pilots. All right, and then look at this minimum wage. This is crazy. 75 cents an hour. Cha-ching. That's awesome. $1. I don't need 1.00. 1.25. Sorry that you can't see this, but I need to see the data points for me to see this. 1.6. By the way, this would be the part that you skip on YouTube. 2.1. You pull the string there on the video thing and move along. And if you're typing slower than me, holy criminies. Once I'm done typing, I'm moving on, man. 3.80, 4.25, 5.15. I do remember this. Right at the turn, it was still like crummy $5.15 for minimum wage. Remember going to make copies in the copy room? They have the minimum wage thing still sitting there. Now it's way different. Anyone know what minimum wage is now? There's a big argument fourth hour. Anyone know what it is? Is it like 13, 12? Isn't it? What is it? 12.75? Is that Illinois? Okay, great. I think that's good. 5.15 even in 2005 is redonkulous. That's a joke. But anyway, and then we can make extrapolations. It was kind of a good thing. They actually, on the next chart, they put purchasing power of dollars just to show like how kind of unfair the minimum wage is if people, had jobs like that. Is that really good for like living purposes? And obviously it's not. It's good for, high schoolers just gathering some money, but not for supporting a family kind of thing. So that's been the big debates anyway. All right, now do this for me. Go to y equals. I already have this turned. Oh no, I forgot to tell my other hour to turn their plots back off. So we're actually going to go into this plot feature. I'm going to show you a new thing from your graphing calculator that you don't even have to do tonight, but I'm still going to show you it. So hit second y equals, and then it does go into those stat plots. And notice my 1 is blackened, your is not, but go into that 1 and press enter. Now you're in plot 1, and I think it toggles it on right now. This is black here, right? Isn't plot 1 black? Okay. And then I just want you to understand these things. You can plot a series of dots. That's what this first one is. You can connect those dots to see what would the graph look like. You know what this is? That's a bar graph. You can make a bar graph out of these. You know what that is? That's a box and whisker. And then it actually has, if there are outliers, I hope you remember the term outliers. That means data that's so bad, if it was test, that we shouldn't even count it in our data. That actually happens. Sometimes an outlier could be so good. Someone could get 100. The next best test is a 68. Whoa, that 100's an outlier. Because the only person that got an A, the next person got a D. This person probably belongs in a different class. Then I got to redo this test for the others. All right. Most of our stuff, we've had a lot of outliers on the bad end. And we know that. We've discussed that. And we got all these things that can help you. And not many people are using them. But that's my complaint for the year. Anyway, blah, blah, blah. So look at that. We did put our list in L1 and L2. We could put it anywhere. We could put an X list in L1 and put another one in L4. You just have to say your Y list is in L4. Input, say it. Output, that's what this is all showing when I show an equation next. All right, but then don't hit graph. Hit window. What were your X values? Between what and what? What was the first year I plugged in? 55. What was my last year I plugged in? 105. So you know what I'm going to do? A little bit better than that. I'm going to expand the window higher than that. And I'm going to go to 120 because what 120 represents is the year 2020, right? Okay. And then, just so you just expand it. But I really need it just from 55 to 105 so I can see the points. And then what were the Y values? Are these appropriate for this one? Not quite. My first one was 75 cents. My last one was 5.15. I'm still going to go to $10. I want to go a little bit bigger. And now when I look at the graph, boom, now I can see the plots of the data. What kind of picture would almost connect that data but not perfectly? Starts with an L yet again. Linear. Now we're going to go ahead and calculate that on my calculator, but I want to show you some more. Hit stats. Hit edit. Wrong, sorry. Hit stat again. Move over to calculate. There we go. And yeah, you've never seen this before. We never talked about this because in CAT we don't do any statistical kind of stuff. Maybe in math too, you did some stuff where you hit the one variable stats, possibly. But here's what we're going to do. What did we just say? It was what was a perfect graph for this? A line. I don't know why they have two of these. I've always been bothered by this. 8 is actually a linear regression where B is the slope. And hopefully you understand that y equals mx plus b. A just represents the slope when you go ahead and do this. Press enter. If you have an old calculator, just linreg comes up. And then you just press enter and you'll get this. And I guarantee you are not going to get what I get here. We're going to get something different. But again, look at that. One more chance. Is your X list L1? Yes. Is your Y list L2? Yes. Don't worry about frequency list. I am going to do this. This is a good little feature, and it was a good thing I didn't make a video last hour because I forgot how to find this. When I get this equation, I want to store it in Y1 so I could see the graph go through those points. But here's what we got to do. It's in vars, which stands for variables. So I hit vars. Got it? Then hit Y vars. Then hit enter on function. And finally, I get Y1 there. This is alternate. You don't have to do this tonight. You don't have to plot any of the points and see them. You're just going to do what I show you on the next example. Okay, so you don't have to do all of this. You just have to calculate. And then you're not going to get what I get. You are not going to get an R squared and an R value. Am I correct? Yes or no? Does anyone see R squared or R? Raise your hand. Here's what we need to do right now. And then once you do this, you don't have to do it again. Second catalog, second 0. Now, I will tell you what the catalog is every single operation that the calculator has. The catalog can find it for you. Here's what you want to do, though. I know what I have to hit. You don't. But if you knew in the future I had to hit like a sign or something like that. I don't know where the sign button is. It's right there, by the way. But then you'd hit S right here, and it goes to S in the menu. So this is a way to toggle through the menu. That's to sample test. Or I want to go to N, something that starts with N. Well, we want to go to something that starts with D. So when you go to the catalog, this is a quick way to move through the catalog fast as opposed to streaming down. And then this is what you want to make sure you turn on. When I go to your calculator and delete your memory, it actually turns your diagnostics off. You don't have to worry about what that means. What it means is you don't get an R and an R squared value. You need to turn your diagnostics on. Press enter, and then go back and do your linreg again. So go back to this operation that you just did. Then when you press enter, boom. What did I tell you your R value should be close to? What number? 1.99, pretty dang good. But really what we're going to look at is our R squared value, which really literally is just this number squared. When R squared equals 1, boom, shakalaka. That is perfect. What that means is every single point in the data set falls exactly on the equation that you selected. And that's a perfect thing. So now that I inserted this in, boom, if you follow my directions with the Y1 thing, there's the line. This is why R squared is not perfect. These distances are a little bit off of the line. The farther these other points are, the worse the R squared value is. It gets less and less away from 1, 0.9, 0.8, 0.7. And that's all you really need to know. That's the mathematical structure of R squared. Okay? Okay. So now what we can predict is what's the minimum wage going to be in the future. Guess what? It wasn't true. Minimum wage really shot up these last couple of years because of people complaining. It's not right. So this model would have to be changed probably, but it's probably going to be that high for a while because it did shoot up really quick to be a justified number for people. It is a very valid problem there. And then anyone ever been in physics? Please raise your hand if you actually been in physics. I bet you this is true what they say on this worksheet. We're going to do one more just for manipulation of the calculator again. Oh my gosh, I hate this program. It is the worst. I got to go like this and then go back and then it'll finally scroll for me. And actually, I saw this in one of my science shows. And I was fascinated by the simplicity of it. I forgot what the show was about, but they did show Galileo's experiment of gravity, of rolling a ball on a ramp and then calculating the distance after 1 second, 2 seconds, 3 seconds. And he noticed from 1 to 2, the distance was different from 1 second to 2 seconds, from 2 to 3. It started speeding up. And he actually put these in data points in and then analyzed what gravity is actually doing. A very simplistic kind of thing. So here's what I want you to do. Put this data in and we'll look at that experiment. Okay, so I'm going to freeze the screen, but I'm going to tell you what you got to do after I do this. Go back up and clear, enter. Move over, clear, enter. And now you got a free list to input. And then I'm going to freeze the screen so you see this in class, 0 through 8. You freeze the computer if you wanted to play along at home if you're doing this. I froze the screen, right? You can see everything? 1, 2, oh, it's the video again. The teacher calling out numbers. 4, 5, 6, 7. Someone just coughed in the middle of my numbers. I can't. You interrupted me there. I'm just kidding. All right. And then I'm going to look at the screen. We have the screen frozen in class here. Oh, you can see that over my shoulder there. So I'm going to look at that screen myself. Of course, at 0 seconds, the ball goes 0 feet. And then at 1 second, he calculated it was 0.75. At 2 seconds, it was 3 feet away. 3 seconds, it was 6.75. I think for sure you can understand that this is not linear. These are starting to get bigger as I go 1 second to the next. There's not a constant rate of change. I know in Math 2, I think they really, in a good way, hammer that idea down. To figure out what kind of function would mirror this data. 27, 36.75. And again, this is all you have to do on your calculator. You will not have to do what I'm doing next. You will not have to plot the data, but I'm going to do it just for giggles. Okay, so you should have been faster than me. I'm going to unfreeze the screen so you see my data values. In 3, 2, 1, go. And then we're going to go to our stats. Nope, I do want to see this. By the way, we're still plotted. I'm going to delete that line. I don't want that in Y1 anymore. I still have my plot on, and actually you can change that plot by going up, and that's what I'm going to ask you to do when you're done today. Turn that off because that's going to cause your calculator a lot of problems. Having your plot on with no data, your calculator will shut down. So make sure that we do turn that off when we're done today. But I want it on. My window must change. What were my seconds? From what to what? 0. Why did I go -5 then? I want to go a little bit more. I want to see the data. to what many seconds? 8. I want to go to like 10, 20 maybe, just to see where this is headed, but I'll stop at 10. And then what was my feet? Zzz. But guess what? I'm going to go -5 just to give it some more space. Then how many feet did it go to? 48, right? I should have done 100, and I should have done like 20 seconds. So I can analyze what was going to happen in the future. Where's this graph headed? And then we could kind of make that correlation. Enter, and then graph. Boom. Is that linear? Yes or no? No, and I think we knew that from looking at the data. What does it look like? Actually, exponential is a good guess. So funny, I actually tried exponential and I got an error. There's a reason. What's anything to the 0 power? Is it 0? No, it's 1. 0, 0 really screws up exponential and logarithmic. Another possibility could have been logarithmic. So what do you think that leaves? This is half of a what? Parabola, parabolic. So here's where we're going to go. We're going to go to stats, calculate, and which one of these is a parabola? It's on the screen here. I'm not necessarily on it. Which one's a parabola? 5, quadratic. So you got to know your terms. Quadratic reg. Enter, L1, L2. You can store it or not. I could do it again just to see for giggles. You don't have to do this tonight, though. All you have to do is analyze the R squared. Vars, Y vars, Y1. Calculate. Boom. Hey, everybody, look at the R squared value. What is it? 1. Boom shakalaka. That means every single data point lands exactly on this equation. This is a perfect, 100% perfect equation for the data. And that's what I want you to know tonight. And that's what you're trying to get going on there. Boom. Of course, in the past, this doesn't count. What time's the bell ring on us? 20? Okay, fine. All right. But I want you to see this now and look at your worksheet. They actually say one of 4 choices, and you're only doing 1 through 10. And you're only doing 1 through 10, and you're only checking which ones do they say? Linear, what's up in the directions? Logarithmic, exponential, or power. Look right here. Here's linear. And what you're going to check is, let's do a linear regression on the same data. Would I pick this when the R squared value is 0.92? Or do I pick the R squared value that's equal to 1? Which one do we pick? The 1. The better the R squared value, the better the formula. And then you write the formula on your sheet of paper. So you want to check which one is the best. You insert your data and calculate 4 different regressions. Which one has the best R squared? Put it on your paper, and you're done for that question. All right, so just to cover one more time, where are these all at? Stat calculate. There's ln. There's quadratic. There is ln, which is logarithmic, natural log regression. And then here's the 4th one, exponential regression. You check all 4 of those and see which one has the best R squared value. Do not do 11 and 12. Those are 2 different regressions that I'll talk about tomorrow. All right, so don't do 11 and 12 on your homework. Is it 11 and 12, right? Wasn't there 1 through 12? Is that correct? 11 and 12 are called logistic, which was one of our family of functions in our 12 book thing. Actually, truthfully. And I'm trying to stop the movie and I'm trying to figure out how to do that. This? No, that's my picture. This is fun. Where the heck is the... oh, there it is. Samuel is fumbling with technology. It's always fun.